Okay, so the question we have here today is to find the area between two curves. Y is equal to x cubed minus 2x squared plus 2x minus 2, and another curve y is equal to x squared minus 2. Now the way to find the area between two curves is through integration. Through your book, your textbook, you should have seen something like this. The area between two curves is basically f of x minus g of x bounded by the limits, essentially where they cross the x-axis. You're essentially finding the area underneath one curve and then taking it away from the area beneath another curve. And that would be if you wanted to find the equation for area between two curves. But what we're actually looking at in this is to find the area of multiple intersections. And we would in fact use this equation, which is basically f of x minus g of x plus the other area of f of x minus g of x. And the area of A would be C to A, those bounds, and then this one would be B to C. So I'm just going to hide them very quickly, and I'm going to put this equation up, which is the equation that we're going to be going on for this example. Now, I want to bring your attention to this. I've basically plugged in f of x into this simulator. It's called Geogebra. It's pretty handy, but it allows you to map what they would look like. And essentially what it's doing is it's giving you values for when, say, x is minus 2, minus 1, 1, 0, etc. And the same for the y is equal to x squared minus 2. Now this is our equation x squared minus 2. It's a quadratic equation. And our other one, which is in orange, is obviously moving from deep below the y-axis to positive 4. So I'm going to go back here and I'm just going to put in that graph. Move this around. And there, basically this is what the area we're trying to find. As you can see here, we have y is equal to gx, x squared minus 2, and y is equal to f of x. And then if I put in these, this is essentially the areas that we're trying to find, A and B. And then for the, say, the A part, we're having to find the area between C and A. And then for the B part, we're finding the area between B and C. So I'm just going to put them all in. I can now hide this, and we can essentially start. So the first thing I need to do is to find the areas bounded on the two curves. Now it looks pretty obvious, like the intersection is going to be 2, when x is equal to 1 and when x is equal to 0, but I need to find them to make sure. Now the first thing you can see is y is equal to something and y is equal to something. So I'm going to let the two equations equal each other. So I'm going to say So I'm going to say x cubed rather, minus 2x squared plus 2 of x minus 2 is equal to x squared minus 2. And I'm going to just basically undo that for a second, and I'm going to say minus x squared plus 2 is equal to 0. Now, that's going to give us an equation like this. So very quickly, I'm going to see that minus x squareds are going to match up. I have this is going to cancel with this. So I'm left with x cubed minus 3x squared plus 2x is equal to 0. Now, that equation might be slightly different than what you said, but it's essentially just x by x squared minus 3x plus 2, and hopefully that's the kind of equation we're more used to. So I can say x, and then x minus 1, x minus 2, which means I have x is equal to 0, x is equal to 1, and x is equal to 2. Now obviously I could find the y coordinates also, but I don't need to do that for this. I'm basically just looking for the x coordinates. So I'm left with a is equal to b, a plus b, is equal to the integral. Now I'm looking for f of x minus g of x, but I've already taken away f of x, so f of x was x squared minus 2x plus 2x minus 2, and g of x was x squared minus 2. I've already done that, and I got this answer. So I'm just going to basically plug that in, and my first is going to be 1 and 0. So I can say this is equal to a, this is equal to c, and this is equal to b. And it's going to be x cubed minus 3x squared plus 2x d of x plus I have 2 and 1 x cubed minus 3x squared plus 2x d of x. And integrating them very quickly, you get x 4 over 4 minus 3x cubed over 3 plus 2x squared over 2 followed by 1 and 0 plus the same thing, x4 over 4 minus 3 over 3x cubed plus 2x squared over 2, and this time I'm left with 2 and 1. Now that's just going to go to 1, that's going to go to 1, that's going to go to 1, and that's going to go to 1. So I would be left here with 1, this will be a quarter, minus 1 plus 1, they're obviously going to cancel, minus 0, this algebra will be 0, so that's going to be what I have in 1, plus it's going to be 16 over 4 minus 2 cubed 8 plus x squared, it's going to be 2 squared is going to be 4, so that's 4 minus this, that's all going to go to 0, and then minus, and how it's basically the same thing, quarter minus 1 plus 1. And that very quickly is going to go to a quarter plus minus a quarter. Now the area can't be a minus a quarter, so you're eventually going to be left with a half units squared. And that is the answer. I suppose starting off, it looks like a quite complicated question, especially considering you're not really given an awful lot of information. But if you stick to the formula, especially for the area bound by two curves for integration, a plus b is equal to f of x minus g of x plus f of x minus g of x, the integral of f of x minus g of x. It's pretty easy to work it all out. Yep. Thank you. Any questions, leave them in the comments. Thank you very much.